For the rest of today and tomorrow, I do want to strongly recommend that you guys practice the stoichiometry. When you guys write your quizzes and tests in this unit, you're going to discover it's a lot of math. Like, pretty much every question is a pretty intense math question where it usually looks something like this. I'm going to give you an initial value, like say in grams. You're going to do like a mole over grams to cancel. You're going to do some sort of ratio to cancel something else. And then you're usually going to do like a grams per mole and do another cancel. And I need you guys to get fairly quick and efficient at these, because this unit really shows who knows their stuff and who doesn't. Because for example, if I say we're talking about calcium chloride, I need you to instinctively know calcium chloride is good. And you have to be able to find its molar mass pretty quickly. Right? Because you're going to do a lot of calculations, and if you're always in your data booklet going, where the heck is calcium again? Where is chlorine, right? Like, you got to be pretty proficient at this in order to do well. And this unit is probably the biggest reason why I wanted to do a bunch of review at the beginning of the year, because you need to be able to write a chemical equation, balance the chemical equation, find all of the molar masses, and do that in a very timely manner. Because if you can't do it fairly quickly, like, you're never going to finish. Does that make sense? So make sure that this is something that you practice, because not that speed is the only thing that matters, but to some degree it does. You know what I mean? Because if you've looked at today's notes, it's just a whole bunch of examples. You know, once you get the concept of how to do stoichiometry, it's all the same. You know, you're just canceling units out. But you have to make sure that all those little details, you can't screw those up. Because if you make one little mistake, then the whole question's wrong. That makes sense? So today's goal is now to include some other units. Main quantities that we've been working with so far are moles and grams. That's all we've really done so far in this unit. But we can measure things in things like volume, like liters. We could even do concentration. So what I want to do today is throw some variations into the questions we solve. So, like I said, it's mostly examples. So let's just jump right in. Example. How much copper would you need to produce 25.8 grams of gold if you reacted solid copper with gold 1 nitrate? To be honest, this is actually what we've already been doing. This is nothing new. So where should I start? How do I get going on a question like this? All right, so I can start with 25.8 grams of gold. That's a good place to start. Yeah. What's next? Do we want to work with grams? Moles is always the unit we need to work with, so I need to have a mole over a gram. And where do I find that number? Gold's number on the periodic table, it's a molar mass, yeah. So again, I don't mind if you need to look it up in your data table, but I mean, hopefully you can find it quickly. Because if you're spending 5 minutes finding where gold is, it's going to take you a while to solve questions. So, gold's molar mass is? Thank you. 196.97. Okay, the next thing we want to do is get rid of gold. What do we actually want to try to find? What's the question actually asking us to solve for? How much copper? Okay, so we need copper. Here we run into a bit of a problem though. I need to know the ratio of copper to gold. Do I have that? How do I find that? Is that louder? We need to write a balanced chemical equation, right? So this is really going to draw on our skills from like our review unit in grade 10, because if you don't write your balanced chemical equation properly, like the whole thing's screwed. Does that make sense? So let's read through here again. We want to react solid copper with gold 1 nitrate. What is gold 1 nitrate's formula going to be? Because if you can't get that formula right, it's also going to screw things up. Well, here's gold. What's a nitrate? NO3. How do their charges work? Do we need any brackets or 2s or stuff like that? Well, we said it's gold 1. What's nitrate's charge? -1. They fit together perfectly. We're good to go. This isn't really relevant, but I guess we could look up whether this is solid, liquid, aqueous in our data table. Is gold and nitrate a solid or an aqueous on that one chart? It is, yeah. That probably wasn't the end of the world, getting whether it was solid or aqueous, but I always like to recommend that you should write a state of matter afterwards. Okay, well, it says that we're going to try to produce gold, so that's AU solid. What's going to be the other thing that gets created then? What kind of reaction is happening? Single replacement, yeah. So that means we're going to need copper going with nitrate. Well, how do I put the copper and the nitrate together? What charge does... Well, we know nitrate is -1. What charge does copper have? Actually, copper has 2 charges. Which one's more common? How do we know this? Because it's first. Yeah, whichever one is first is more common. So apparently copper 2 is more common. Again, there's a lot of little things you have to get right to solve this problem. Does that make sense? That's what makes Stoich so hard, is that you might understand the general concept, but like if you did copper 1 instead of copper 2, you're going to get it wrong. So based on that, you're going to need to put a 2 afterwards. And I'm pretty sure this one's aqueous as well. To be honest, the aqueous part is not the relevant part for solving this question. Last thing, I need to balance this bad boy. So how do I balance it? Fantastic, good job. Okay, so hopefully what we just did there for writing that balanced equation, hopefully that's coming faster. I hate putting time limits on people, but I mean, at the end of the day, when you guys write a diploma exam, if you keep going on to Chem 30, you have to be able to answer a question in about 2 minutes. Like, there is a time limit eventually. I don't want to put a time limit on you now, but I mean, that is how we know you're proficient at this. So, 2-to-1 ratio. Wait, what's our last step then? Yeah, throw it back into grams. So we had to go grams to moles, use our recipe. Now we've got to go back into grams, so that's grams over mole. And where do I find that number? Same thing, periodic table, it's copper's number. So 63.55. It's not a requirement of mine to say that you memorize these things, but I hope you agree that, like, boy, it helps. Like, it really helps. So I'm going to recommend practice, practice, practice. I know it's the same thing over and over again, but I mean, that's how you get better. That's how you get fluent at this. So now you just need to do a whole bunch of math. So let's just make sure we all get the same answer. I got 4.16. Same thing? And that would be grams of copper. And I can prove the units by canceling them all. So let me just grab I used a crayon last time. It worked really well. This grams right here should cancel with this grams here. This should cancel with this one. This one should cancel with this one. And I'm left with coppers, and I'm left with grams. This right here is stoichiometry. To be honest, I've taught you guys pretty much most of the unit already. If you can understand how unit canceling works, you know the basics. The key now is, can you use these skills, extrapolate them, and solve slightly different problems? Because not every question is going to be like grams to grams. Okay, I'm going to throw some twists in, see if you can handle that. This makes sense then? Okay, let's try a twist then. The twist we're going to have now is that we could work with gases and use a number like 22.4 or 22.8. That could be part of solving this. So let's do an example. We've got hydrogen gas produced when sodium metal reacts with water. We want to find a mass of sodium. Here's the twist. I'm giving you a liters number to start with. Usually I gave you a grams number to start with, but now I'm giving you a liters number. So now we need to be able to adapt, apply the same skills, but now we've got a 15.6 liters of hydrogen to start with. Is a molar mass going to be helpful? Like if I did a moles over grams, is this actually going to accomplish anything? Nope. All right, so hopefully you kind of get what I'm going for here. A molar mass in this instance is not useful. Well, we need to get rid of liters. So I need a liters on the bottom. Grams on top would be great if I had a number that could get me grams per liter, but I don't have a grams per liter number. I could do moles. Let's try moles. We need a moles-liter relationship for hydrogen gas, and here's the real kicker. It's an SATP. Didn't we learn such a number in the last unit? There are 24.8 liters in a mole at SATP. We can kind of combine last unit and this unit now. So where does that 24.8 go, on the top or the bottom? It goes on the bottom. So I hope you guys get my point here. I mean, we're throwing a twist into it, throwing a monkey wrench in there and saying, we're not going with grams, we're going to go with liters. But look, hey, liters still cancels. All right. Well, I don't know that we need a molar mass, because we actually want moles, don't we? But we don't want moles of hydrogen. What do we actually want? Yeah, we want the mass of sodium. So we need a sodium to hydrogen relationship. So brief aside now, we need to find that recipe. So again, we gotta start from the scratch. We gotta write a balanced equation. So let's try to write an equation. It says hydrogen gas is produced. So that means that H gas must be on this side here, when sodium metal reacts with water. So sodium metal, looks like it reacted with water. It made hydrogen gas. It would. That would be the other thing it would make. It would make NaOH. Well done. The reason why it's going to make NaOH is that H2O is really H and OH. So it's actually single replacement. The Na is going to go with the OH, and the H's will go by themselves. NaOH, I mean, we don't really need the state of matter to answer the question, but I like I said, I always like you just to put something down there, so just throw an aqueous there. I mean, you can look it up if you want. I think it's aqueous. Is it balanced? Everything's balanced but hydrogen, which kind of sucks. Alright, so how do I balance it? Okay, well, sodium's balanced, so let's try not to change sodium yet. And oxygen's balanced, but if I need to get, there's 2 hydrogens right here to 3 right there. So I think I'm going to have to put at least a 2 here and make it 4 to 3. I can't really change this guy right here very easily, but I could throw a 2 there. That would do it.
Yeah.
There we go. So we got it balanced finally. One of the things that you'll notice about, like I said, this unit is that it's really going to draw on a lot of skills. Does that make sense? Like all of these skills that you learned in grade 10 and that we did review for at the beginning of this year, and even the stuff that we started our year with in solutions and gases, this unit is kind of the culmination of all of those skills. You kind of have to be good at basically everything.
I just have a question.
Yeah, fire away.
It says on the one side there's 2.
This one here?
Yeah, no, I'm sorry. The H2O. So how did we end up with 3 on the other side? Because we started with 2.
Because it was H2O to H2 and NaOH.
Just because we're told it's H2?
Yeah, well, it said it was hydrogen gas.
Right.
And hydrogen gas always comes in groups of 2. It's a diatomic one.
Exactly.
Does that answer your question? Or?
Well, we were told in the question, yeah, hydrogen gas. But what if you weren't told?
You wouldn't have enough information to solve the question, I guess. Like, yeah, you'd have to be given at least some framework to know what to start with. Is that coming from another classroom? Wait, does that work?
Yeah, I just didn't know.
Yeah, you'd have to be given at least a stem of a question that gives you something to start with. Okay, so now we need to know our recipe. So sodium to hydrogen recipe. For every 2 sodiums, you get 1 hydrogen. Wait, last thing, it actually asked for a mass. Perfect, yeah, we're going to need a mole to cancel here, and we'll need to throw grams on top. So I know over here we didn't require a molar mass, but over here we are going to require a molar mass. Whose molar mass though? Sodium's. So good. 22.99. Again, the basic principles of stoichiometry. This is the basic principles here. If you can see how this fits together, you're golden. I'm going to say this a lot though. You got to get all the little details though. Right? Because if you miss any of the little details in balancing your equation, finding molar masses, I mean, yeah, one little mistake and the whole thing's shot. So now I just need your calculator. 15.6 divided by 24.8 times 2 times 22.99. I got 28.9. 28.9, and that would be grams of sodium. How we doing? You guys okay? All right. Like I said, it's more or less the same. Just we're throwing in little twists. So, like there's not much to my notes other than just a whole lot of examples today.
What was your answer?
28.9 grams of sodium. I wrote it up top here. I kind of ran out of room. All right. Okay, next one here then. Another twist. Ammonia can be produced by reacting nitrogen and hydrogen gas. What volume of ammonia at this stuff can be obtained from reacting? Anyways, there's a lot of numbers here now. You might notice that there is a volume, a pressure, and a temperature number. Which is kind of different, isn't it? We didn't use that in the last example. Why don't we start though where we started last time? Let's start with this 7.5 grams of hydrogen. I mean, that's a good place to start. Only I threw a twist in. It's 7.5 kilograms. So times by 1,000. Let's start with 7,500 or 75, that number, grams of hydrogen. Let's start with that number. Okay, well if we start with a grams number, do we want a grams number? No. So we need to get rid of a grams number. We always need to convert to moles. So again, where do I find such a ratio? Periodic table. Hydrogen molar mass. But you need to double it because it's H2 gas, because hydrogen always comes in twos. Again, a little detail. But I mean, you get that detail wrong, it kind of screws you up. So, right. So there's our start. We have now got moles of hydrogen. What am I looking for? Do we want hydrogen?
Ammonia.
We want ammonia. Okay, so I guess the next question is, well, what is ammonia? It is good, NH3. Well, we're at the same place we were the last two examples. We need a ratio. In order to get the ratio, we need an equation. Okay, let's read it out though. You're right, but so ammonia can be produced. So that kind of implies that the NH3 is the product by I think this should have been reacting. Nitrogen and hydrogen gas. So that would be N2 gas and H2 gas. Let's assume that the ammonia is also a gas then, I guess. I have no idea whether it is or not, but I'm just going to write something down there. This was actually on your test a couple of times. So to balance this guy, we need a 2 and a 3. And that's a 1. Does that make sense? So throwing in our recipe, you get 2 ammonias for every 3 hydrogens. We are almost there. Last step. We need we need moles on the bottom. I know that much. And we're looking for what volume? So we need a liters on top. And here comes the next twist. Well, we kind of need to find a liters to mole ratio. Not concentration. You guys remember how at STP it's like 22.4? and at SATP it's 24.8. Are we at either STP or SATP? No. So we're kind of hooped because we'd like to use either 22 or 24 here. But we could find that number. I actually had you guys do this as one of the questions on your assignment. I asked you to prove where those numbers came from. And it hopefully looks something like this. PV equals inert. We wanted to find a volume over moles ratio. So to do that, we had to divide by N and divide by P, so that you get like volume over moles equals RT over P. You guys remember doing this? Well, on your assignment, you were asked to plug in the STP values, but we don't have STP values. But we still have values we can use. What's the R value? Always. Sure. Throw units on there, so that's kilopascal, liter, mole kelvins. Temperature. Now, if it was STP or SATP, we'd use those temperatures, but we have a different temperature of 90 Celsius. So, put it to Kelvin, yeah. So that's actually 363 Kelvin. Let's put a little note here. This is 90 Celsius.
Okay. Why is the KPA one? Why don't you have a number?
Sorry, say this again?
Why don't you have the number of KPA there?
Of KPA for pressure?
Yeah.
Oh, I do actually. That's the one that's going to go on the bottom.
Oh, okay.
Because that's the one I have to figure out last. Is I also need to have a pressure number. If it was STP, it would be 101,325. If it was SATP, it would be 100. But we were actually given it at 426 kPa. So I'm going to throw that in here. Essentially what I'm doing is I'm finding a liters per mole number that's not for STP or for SATP, but it's for whatever our values were. So I'm making my own liters per mole number by doing this step here. Hopefully you'll see that kPa's cancels, kelvins cancels, and the units I'm left with are liters per mole. L and mole. So it's probably not going to be 22.4 or 24.8. It's going to be its own unique number. We just got to find what it is. 831, 363, 426. Anybody else try this yet? I got, 7.08. It goes past that. So like I'm just gonna write down the 7.08, but I got like 7.0810563338. So we weren't given a liters per mole number, but we had a way of finding one. So that number now goes up here. 7.08. I'm just gonna put dots to indicate that there is like more digits there. So this is the other twist I wanted to show you, is we can still solve with gases. If I don't have SATP or STP, I can actually make my own number. I'm just going to put a note here. Find your own liters per mole value by doing what we did down here. I would have to give you a temperature and pressure, though. Like if I don't give you a temperature and pressure, we can't solve something like this. Well, I mean, that does make sense. We started with 7.5 kilograms of hydrogen. Think about that for a second here. How much does hydrogen weigh? Probably not much, right? Like, hydrogen is a small, light gas. So if you have 7.5 kilograms of it, you have a lot of gas. 75,000 divided by 202 times 2 over 3 times that 7.08 number, and I'm going to use the whole thing if I can. Yes? Okay, well let's talk sig digs here. Let me write down my number first though. I got 17527 liters. But you're right, we gotta sig dig this properly. So based on our values, this had 2 sig digs. This had 3. This one here appears to have 2. But technically in Kelvin it has 3. But that being said, this 7.5 kilograms only actually had 2 sig digs. So we're gonna need to round this to like 1.8 times 10 to the 4 liters. I'll just box that. There's our answer.
I just wasn't sure because, like, temperature when you convert it. I didn't know if it was the same for kilograms.
No, because same thing like in kilograms. It's like really this could have been like 7.5 times 10 to the 3 is like probably a better way of showing that one there. I know it appears like it has 4 sig digs, but it really only should have had 2. That's a good question to ask though. Alright. Questions? Did that make sense? I often tell my my kids when I teach calculus this, but I think it applies to you guys now. I always feel like there's like 3 levels of understanding. The first level of understanding is that actually you don't understand, and if you watch me do it, it went over your head and you're like, yeah, you didn't get it. But hopefully that's not you, hopefully. The second level of understanding is you can watch someone else do it and go, yeah, I see what you did. I can follow. And I'm hoping most of you are at least at that point where you're like looking at it going, oh, I see that one went there. The third level though is, well, now can you do it yourself without any help? The fourth level is, can you also get it right? Okay. So I've done a bunch of examples. Why don't you guys see whether you can try this next one here without my help? I mean, I've given you the basics. There's a new twist on this one. Like this one has a different twist than we had last time. But why don't you guys take a stab at it? I'll give you 5 minutes, and then afterwards we'll go through it together. Try the pencil first.
Of ammonia and phosphoric acid are used to produce ammonium hydrogen phosphate. What volume of 14 ammonia will be needed for the ammonia to completely react with 100 kiloliters of 12.9 moles per liter of H3PO4? So, let's start breaking that down. What's the first thing?
Yeah.
Does it mean that the ammonium phosphate on the one?
Like ammonium hydrogen phosphate would be like NH4,
That he already
and then hydrogen phosphate is actually its own thing, like it's an H2PO.
They're two separate things. How it's written, I think H3PO4.
This guy right here.
Yeah, I'm the stupid one.
So it's a solution of ammonia and phosphoric acid are used to produce ammonium hydrogen phosphate. And then what volume of 14 liter ammonia needed for the ammonia to completely react. So we got that one.
You really can't check NH3, so you just have to take a guess. It's probably liquid or gas. To be honest, it doesn't really affect our chemical equation. I just always say, like, just put something. If you put aqueous, I wouldn't mark it wrong. Sure, gas works. Maybe a liquid. Not.
What's its most common?
Probably liquid. Like when I have ammonia in my lab, I have it liquid. But you know, it's one of those volatile type things where it wouldn't be hard to make it into gas. So I think it is probably temperature dependent. Like if we were doing this at room temperature, it's probably okay. If we were doing it at, boil it up to like say 50, 60 degrees, I bet you it'd be gas. Again, don't split hairs over it, just put something. Okay, so ammonium hydrogen phosphate is actually 2 things. That is ammonium, and hydrogen phosphate is this guy right here. They're 2 separate ions that have actually been put together in a formula. So like this guy's got a -2 charge, and that guy's got a +1 charge. So you're gonna need 2 of these and 1 of those all together in one big like super molecule. I know, weird twist.
Oh, it's ammonia.
It's ammonium hydrogen phosphate, but ammonia is what helps make it. What's up?
I'm gonna use these things.
Yeah, or you can look at the phosphate above it there and be like you through. But yeah, that looks good. Your product is not looking properly though. It's not ammonia hydrogen phosphate, it was ammonium hydrogen phosphate. And by the way, hydrogen phosphate is actually like, yeah, ammonia is a positive ion reacting with a negative ion over here. Yeah, so you're actually going to need
Ammonia, hydrogen, phosphate.
ions for your one hydrogen phosphate ion. Yes, you have it correct.
Did you balance it?
Oh, hang on. Is this
NH4,
because the first one was ammonia.
H2, PO4. So it's ammonia,
If you now have it ready to balance, it's not ready to balance.
say that.
Probably not ready to balance it. Hoping all it takes is a 2 here though. Because you definitely need to double use nitrogen too.
Yeah, I'm like, I know what's wrong. Well, start somewhere.
Or hydrogen phosphate is NH4.
Oh, I know what you did. Oh, I did it.
Yeah, well, there's two different things. There's ammonium dihydrogen phosphate or ammonium hydrogen
So it takes, I'm sure you need whatever this is, needs to be double, because this one needs to be double balanced. So there's like 2 nitrogens right there. You know, 3 nitrogens there. Well, I would start with 2 here myself. Because then now there's 2 nitrogens, make that 2 nitrogens there, right? Then here your phosphate first. Since that phosphate there. And simply with your O's, right? You've got PO4. You got PO4, so that's good. So now check your hydrogens. You have 1 plus, that's 8, I guess. 9 over here. 3. That's actually 6.
Yeah.
You're good actually. That's 2 times 3 is 6 hydrogens. Oh, 3 more.
So he has the ability
See,
to.
actually, this is balanced now.
It's
Hard to get the first equation balanced, right? Now you get the Stoich part where it's like, cancel stuff. You just did 2 of
So
them.
we'll ask him.
So when I was looking at this here, like this nitrogen right here, there's 2 of them, right? So that's why I was like, well, there's only 1 nitrogen here, so I put a 2 in front of that guy.
Ammonium hydrogen.
And then I said, look, here you got a PO4. And there you got a PO4, so I don't really want to change that. So I looked at hydrogen and said, well, now there's like 4 times 2, so that's 3. I'm like, oh, that's 1 more makes 9. Over here you've got 3. You've got 3 more. But we put a 2 in front though. So yeah, you're good to go as soon as you have that. So there's your balanced equation. So now do the Stoich line. So we'll be like halfway through.
Yeah, we're gonna find out if we've got the right start here. So of course, since you weren't here, I went on the internet and found this for ammonium hydrogen phosphate. And I.
Yes, that works.
So you kind of did.
No, I think you just need a bracket though, like H4 bracket to PO4. It's probably how we, HPO4 is probably how we'd write it. Because you have it right there, yeah.
But they put, they put the 2, okay. It's just the way it showed, I'll show
Yeah.
you. And maybe, you know.
Andrew hydrogen phosphate. Yeah, so this too is probably should have been like a subscript. Yeah, because it looks like on there they don't actually have any subscripts written. Because it looks like the 4 was also written as a big number.
Oh, okay, yeah.
Because this thing right here is ammonium,
Right. There you go.
and this thing right here, if you have your periodic table, is called a hydrogen phosphate.
Oh, okay.
I'll just grab a periodic table and show you real quick, and then you can show Nick in a second.
Up on this again here. We don't use it regularly, but the hydrogen phosphate is like a kind of zone.
Right, so that's why it was 2 negative, and then you had to have 2 agree with the positive 1?
Yes.
Okay. All right, so here's what we got. Alright, so we have ammonia in H3 and then hydrogen.
No, you need it.
How much more time should I give you guys to try? A few more minutes? Anybody have an answer?
Yeah.
Okay, hold on to the answer. Don't yell it out so everyone else can try it. Like I said, this is kind of the twist is now, can you take it from, I've shown you some stuff, to can you do it yourself? So, I mean, if you can't, don't worry about it. I mean, it's early, but you know, this is what we want to work on is, can you extrapolate your skills to a new and unique situation? Cole, did you have a question?
So, when are you going to do our progress logs?
I just need to finish marking the assignment, and then you should be able to do the progress logs. That's the last thing I got to mark.
Probably never want to do that
Okay, because that's what we have written there. What volume of 14.8 moles per liter ammonia will be needed. So do we balance it? Okay, so the main thing now is that we just need to balance this. So we know the recipe, we know the ratios. So we've got, right, so we have 6 H's right here plus 1.
Right.
This is what, this is the, here we have N, this is what is produced. Here's the reactants, here's the, it's produced in H4, and HPO4. So this is, so here's 8 H's plus 1 more is 9 H's. So let's see if we've got 9, how we can bring 9 H's over here. So we've got 3 H's here and 3 H's here. So that makes 6. We just need 3 more H's.
Got an answer? Cool.
If we had made this into 6 H's, we're putting 2.
Okay, why don't we give this a try? I mean, keep working a little bit if you are, try to multitask. One of the things I want to point out is that this is actually based on our first unit. All of these numbers are about solutions. And if you guys remember solutions, we can measure concentrations. One thing my grade 12s will often forget is that if I write something like 14.8 capital M, you remember what capital M stands for? Yeah, which is moles per liter. When my grade 12s do this, they always seem to forget that capital M means moles per liter. This is a ratio that we can use in a Stoich equation if needed, based on moles per liter. Gases are usually measured in liters per mole, but solutions are usually measured in moles per liter, or capital M. So let's give this a try. The first thing you need, though, is a balanced equation. And I got it started, except for this ammonium hydrogen phosphate. And I chatted with a few of you while you were working. Ammonium is NH4 plus, and hydrogen phosphate is actually like a thing. It's a PO4 2 negative. So to put it together, you're going to need 2 of the ammonias and then 1 of the hydrogen phosphate. Let's go with aqueous. Sure, why not? Again, does it really matter? No, don't split hairs over it. But please just write something. It's like punctuation in chemistry. It would be like not putting a period at the end of your sentence. Only you just put an exclamation mark. Whatever. Sure. Okay, I do need to balance it. This one is pretty easy to balance, though. You just need a 2 here. If you didn't catch that already, you can check my work, but it just needs a 2. So now for the Stoich part. Where's a good starting point? Yeah, I would always start with a number that is not a ratio, because we're going to use our ratios to convert. So I'm going to start with 1,000 liters of H3PO4, because a kiloliter is a 1,000. Do I want liters? No, we want moles. So liters cancels. I need to find a moles per liter number that's applicable. We actually have two of them. I have a moles per liter number here, but that's for ammonia. Here, though, I have a moles per liter number for H3PO4. So the 12.9 goes there. Does that work? Then we no longer want to know about H3PO4 anymore, and we would rather know about ammonia. So that is a 2-to-1 ratio. And then last step is we no longer want to have moles. We'd like to go back to volume, liters. So we need a liters per mole number again. Do I have a liters mole number though for ammonia? Sure, it's this guy right here. But you gotta be really careful here. The 14.8 goes with moles, not with liters. So the 14.8 is actually on the bottom. So if you can figure out how to put all this together, then it's just a calculator problem. So let me see whether I can get an answer. Hello. I got 1743 liters. Anybody get that? Good for you guys. We do need to do sig digs though. So I only get 3, so you could do like say 1.74 kiloliters. You could have said 1.74 times 10 to the 3 liters. Both of those would be valid. But props to you guys. If you got that by yourself, well done. Because that's, like I said, that's your next challenge is I've shown you the skills. Now can you solve new and unique problems? Things that you haven't seen quite before. Okay, I got one last example to do here. What works best? Do you guys think you have the hang of it? Or should I do this last one here? You guys want to try it yourselves? Alright, do the same thing. Take 5 minutes or so, try this last one yourselves. I mean, I've given you the framework for it.
You need 3 sig digs, so you gotta throw the 4 afterwards. 1.74.
Mr. Talk.
Yeah.
What do they work with tomorrow?
Too loud to hear.
What do they work with tomorrow?
What did you say was tomorrow?
They,
Tomorrow is Flex Friday.
we didn't, will come up and, you get all of that.
Unless he had time.
Yeah, if I've got a lab today with my Science 24s. So as soon as I'm done with them though, I'll come downstairs and see if there's any time to do stuff. So I mean, it won't be as much as normal, but I'll get it what we can.
Because I said to him, you can't just move on to that until you
Should go over the mistakes, for sure. Yeah. Maybe if you guys look over the start, and if there's ones that you still don't know why it's wrong, then come back and talk to me.
Then I gotta go.
Okay.
I don't know where so what I will be. See when it's not gonna be up there.
Okay.
It's tomorrow.
Okay.
Have fun day.
Yeah, tomorrow's Flex Friday, so whatever is best for your time tomorrow.
Yeah, we're kind of okay in English, so we're going to
Work on this.
Can I leave that with you for
Sure.
this lecture?
Sure.
Okay.
There you go.
You don't have to bring it to me. I'll just get it tomorrow.
So for those of you guys who are kind of working on this one, maybe I should give some pieces along the way. We need to write that equation at some point. Why don't we try writing it first? It says that sulfuric acid is neutralizing potassium hydroxide. What's sulfuric acid? Well done, good. Yeah, H2SO4. I'll just go aqueous. And potassium hydroxide will be KOH, also aqueous. Wait, what's this gonna form? Good, yeah, it's gonna form water. Well done, K2SO4. I'm gonna assume that that might be aqueous. I don't know. I don't really care actually. I'm just gonna go aqueous. Good job on that. Now we need to balance it. Mr. Forster. What are you looking for?
Oh, not those two. When you're done. No, when you're done doing what you're doing here, when they're free, have them come.
Okay. You definitely need a 2 in front of the KOH, but I think you also need a 2 in front of the water to make it work. So I'll give you guys that to start, because you do need a balanced equation. This is balanced. Now see what you can do in terms of the stoichiometry. It's got a twist I haven't shown you before. So see if you can handle that twist. If not, then I'll walk you through it, obviously.
There's two like single numbers.
There is, I know, that's the twist today.
Okay.
That's the twist, yeah. I mean, I'll show you how in a bit. I do want you to see if you can take a stab at it without me showing you, though.
I think divide by 1,000.
I don't know. I'm sorry.
Like ratios. Not one. What are we looking for? Sulfuric acid. So since we're looking for the acid number, those ones are going to go like on your right hand side. So let's start with the other stuff that we do know. Let's start with the base number. So like if you're trying to figure out which one to start with, I'd recommend start with the 15.9. And then take it into moles. And then convert it into using a ratio. Let's see.
Maybe I'll say that what I just said to Sean to everybody here. I feel like most of you, hopefully you've noticed that there's 2 different numbers here that are not ratios. You got to start with one of them, but the question is, well, which one should you start with? So then I'd actually work backwards and say, well, what actually are we trying to solve for? And we're trying to solve for a concentration of sulfuric acid. So that means that when we're done over here, we want to work with the H2SO4 number. So this number here is for the acid. I'm going to say let's not start with that number because it's what we don't know about. Let's start with what we do know about, which is the base. So I'd recommend start with 0.0159 liters of your base, which is your KOH, and start with that number. So that'd be the hint I'd give you. Start with the number that you do know stuff about, not with the number that you don't know stuff about. So, see whether that helps at all. I hope you guys are able to get maybe to this part here. Most people probably, when they do this for the first time, they get to here and then they get stumped because they're like, what did I put last? So let's say you stopped here. What would you have? Well, you'd cancel your KOHs, you'd cancel your liters. what units would you have at this point? I'd say you'd have moles of H2SO4. We don't usually want moles, do we? What do we want? Well, we want a concentration. What is the concentration measured in? Measured in moles per liter. So if you were to stop here, it would get you moles. Then you should divide by this liters. I have another way of showing that though. This is how I like to show kids how to do this, because this maybe makes more sense. We currently have moles. What we'd really like to do is have a liters be on the bottom. And that'll be 100 liters like that. See how there's like a moles right here over top of a liters right here? But I don't actually want a ratio sitting up here. So we can't actually leave this blank. So what I just show kids to do is just put a 1 there. And what you're really doing is you're just dividing by liters. So these liters have canceled. These KOHs have canceled. This, actually that's all we need. Because what we're left with then is a moles right here, a liters right here, and it's of H2SO4. So I know it seems kind of odd, but just put a 1 in this spot. I got an answer of 0.0119. It does have a 2.5 afterwards, but I'm just going to go right to 3 sig digs. So I guess you could call this 1.19 times 10 to the minus 2. I'm just going to make it a capital M. You could go moles over liters if you want, but remember capital M is moles over liter. So the twist for this one here is that this last number right here, that's the twist, is that it's not actually a ratio. We just really want to just put the liters on the bottom. So I'm just dividing. And if you need to, just throw a 1 on top so that there's something there. That makes sense? Cool.
That was kind of difficult.
Yeah, I wasn't.
Well, especially a tricky one because you hadn't done it before, right? Now that you've seen one of those before, you'll probably know what to, oh, well, now I know what to do. So that's actually all I got. Basically, there's a lot of examples. And hopefully you'd agree. I mean, they all look very similar. Right? So your job now, you need to practice. Well, I mean, it's one thing, guys, give me like 2 minutes here. It's one thing to watch me do it and even try it yourself, but to become fluent in chemistry, you need to be able to do it fairly quickly too. You know what I mean? Because I'm going to give you 30 questions to do in like an hour and a half. So you can't spend 10 minutes on a question because you'll never finish. Okay? So I really want to recommend over the next couple of days, do some practice. Don't just be like, I'm fine. Because this is all your test is on Monday, is a whole bunch of Stoich questions. Okay. So here's some things to look at. I have a whole bunch of textbook questions you can work on. I do, though, think that the questions I have on my website are probably the best bet to start with. But over the rest of this last half hour, and whatever you do for Flex Friday, practice. That's the best advice I can give you. There is an assignment. You could probably start on it a little bit, but... So, anyways, you guys are free to do whatever you need to, so if you guys got to go find Forrester, go for it.
I haven't got any of the labs back.
The Boyle's Law Lab, I have a whole bunch in my late pile. Did you work with somebody on them? Is it possible that I handed, because I just handed these 2 back here. Kate.
But I know that the one you handed back to Cole today, I didn't work on it with.
Okay, yeah, and he didn't even finish that. It was a 0. So, who did you work with for the other one then?
For the one you handed Cole back, I worked with Shody, and then the other one.
Ken, I don't think I got it from Shody, to be honest. I don't think it was ever handed in.
Yeah.
Because I don't have a mark for him for that either.
Because do you have the mark for my first one?
I do have the mark for your first one, but it wasn't very good. I wanted to chat with you, because you worked with Ryler, right?
I worked with Ryan and Shody.
I do have one here that I have to hand back, but it wasn't very good.
There was one that was with Shody that he said he was going to hand it in.
Okay.
And it was almost done.
This is the first one here. Ugh, just trip there. But it was not very good. Yeah, I mean, a couple of things I want to point out here. Where do I want to start? Like this graph right here, way too small for a graph of this graph paper. Not only that, it should go down like this. And then the other graph should have gone up like this. And again, like same problem was way too small here. Like the graphs, I think you have them backwards, I think, but they didn't work out here. This was kind of a mess, to be honest. Like there's no units anywhere on any of this stuff. It's really unorganized. So I could show you an example of. This is the first one we did, probably about 2 weeks ago now. Most of your post-lab questions are really basic, but this is the one I really want to focus on. I don't think this is you. This looks like Ryland's writing here. But like, to be honest, this is pathetic. It was worth 3 marks. This says the units were, I think it's discovered from ancient scientists and were, I have no idea what the hell that word is. This time went on. Like, I don't think that was you. That's the one that was writing. I don't know, but it was not very good.
Because I can see my rating and I've gotten the marks on whatever one that is.
It wasn't particularly great, to be perfectly honest. So.
Oh, what's more embarrassing, that or just not doing it?
Yeah, both were not that good. So, the other one though, that was when you guys told me you were lacking data or something like that, because Ryland took it with him. Did you ever get that lab finished? So I don't think I have a mark for that one either.
How many lab marks?
There are 3. This is the first one, and then there were 2 other ones. I don't know that I have marks for either of those other ones for you or Shody.
The 3 other ones, like the one that we just did like the other day.
Yeah, we did like 2 of them almost back to back. One was finding R, and then the other one was finding a molar mass using vapor density. Those are those 2. Anyways, do some looking into that with the rest. Yeah, it wasn't. Yeah, it wasn't grade 12 or grade 11 high school science quality, that's for sure.
Hey, how many more units do you have in